The method that most closely resembles the method that we just did of the finding easy products and repeatedly subtracting is the scaffold method or scaffold division. And this is tending to be where we are starting now with division. So the setup for this is like long division. We're going to use easy products, right? So things times 10, times 100, right? Times 2 sometimes because that's an easy one to do, but we're just going to use things that are easy to multiply. And you may be thinking like, maybe you did this, maybe you didn't, but you may be thinking like, oh, I never did this method. Why are we doing this? This is a good introductory method to division. Keep in mind that when students first learn division, they're really still learning their multiplication facts too. So the fact that this uses easy multiples can make that transition a little easier. And it also makes sure that your students understand what division actually is because it's using this repeated subtraction, which is what we're doing. So our setup is going to be like long division. So for example, this one, 60 divided by 22. I would do my long division bar. I'm going to put 60 underneath the division bar since it's my dividend and 22 on the outside since it's my divisor. There is a version of this method where you actually stack the quotients on top. So like as you're going through this process, you would write several numbers here. So if you're doing that method, you would want to leave definitely more space than I've left at the top here because you're going to stack a bunch of numbers there, which actually I think is where the name scaffolding comes from because it looks like scaffolding that's stacked, right? However, the method that I have seen and that we'll use in this course is we're gonna like list our quotients along the side, right? So I've got like my long division bar here, but then I'm gonna put a line, a vertical line coming down from that, and then we're gonna actually add the quotients over here. All right, so this is going to be my setup, and we're going to go through this first example and then the rest of these. So what I'm going to do is I'm going to do the same thing. I'm going to do repeated subtraction essentially. If you want to find some easy multiples, like in this case, easy multiples of 22, like 2 times 22, you can use that. If you just want to do repeated subtraction, you can use that. And keep in mind that yours are going to be different than everybody else's, right? So it just depends on what you pick. So I'll go ahead and I'll show it both ways this time, just so you can see what it looks like. So like if I did subtracting 22, right? What we're doing there is we're saying we're subtracting 22 once, which leaves me with 38. And then can I subtract another 22? I can. So that's another one time. So instead of counting this as like 1, 2, like we did before, I'm actually going to just list a 1 next to each one of these, right? Saying this was once and this was once. And then 38 minus 22 is 16. And then to find our answer, we're going to add these quotients. And so again, my answer here is going to be 2, and then my remainder there was 16 right here. So we could do it that way, just so you can see what it would look like with the stacking. I'll have to leave myself a little bit more room, but it's the same idea. So 60 goes here, 22 goes here, and then what I would do is I would say, okay, let me just make 22 go into that once, which 1 times 22 is 22, subtract that, and I get 38 left. I can make 22 go into that again, so I'd stack it above it. And so that's going to be a remainder of 16. And then again, I'm going to add the things that I stacked there, right? So again, I'm going to get 2 remainder 6. And so that would be what it would look like if you did the stacking. So if you see that, it's the same thing. But we're going to stick with this first way of like having that line drawn and doing our quotients along the right-hand side. And again, yours might look different, so I'm not going to do this with every problem, but I'll show this one again. So maybe instead of subtracting 22 maybe you would instead say, okay, I know 22 times 2 is 44, so I would go ahead and subtract 44. So then I would say, well, that was 22 2 times, right? So let me put my long bar there. And so that was 2 times, which is 16, and 22 doesn't go into 16, so now I don't have anything to add this time, right? But it would still just be 2 remainder 16. So these are all correct ways to show this problem. Let's take a look at the next one. And I'm just going to kind of do these wherever I find room on this page. So 85 divided by 14. This is the same one from earlier. And now I'm just going to stick with showing it this way. So the shortcut that we used earlier was we used the fact that we knew 14 times 5 is 70, right? So that would be a good shortcut I could use. But you could do 14 times 2 is 28, or you could just keep subtracting 14, right? So yours might look different from mine or from your neighbors. So if I subtract 14 5 times, so I'm writing the 5 outside there, that would be 70 that I'm subtracting, which leaves me with 15. Can I subtract any more 14s? Yes, I could subtract one more 14. So that would be one more there. And when I do that, I get 1. Can I subtract any more 14s? I can't, because I only have 1 left over. So I would add my quotients here. 5 plus 1 is 6. And then my remainder there was this 1 that was left over. All right, let's do 97 divided by 15. So we haven't done this one yet, so this is a good one to work on. So I would just look for, you could keep subtracting 15, but I might look for a more efficient way of doing this. So I might look for 15 times 2 is not bad, right? That would be 30. These should be things that can be easy to do in your head. 15 times 10, that would be 150. That's really too big, right? But I could say then that means 15 times 5 would have to be half of that. So that would have to be 75, right? So like you can find quick ways of doing things. I might do 15 times 4, and I'm just erasing to have more room. So you can always have some scratch work like this. So like if 15 times 2 is 30, then 15 times 4 has to be double that, right? So that actually might be a good place to start here. So I might use that one. It doesn't really matter. So I'm going to say that I'm going to subtract 15 4 times, and 4 times 15 is 60. If I subtract that, I get 37. Looking at what I have here, actually, I could subtract it another 2 times. So if I subtract 15 2 more times, that's really subtracting 30, which would leave me with 7. And then I'm trying to subtract 15, and I can't subtract 15 from 7, so this is where I would have to stop. So then if I add my quotients, 4 plus 2 would be 6, and I have a remainder of 7. All right, so this is how I would set up the next one is 582 divided by 18 with my long division and then my bar along the side. And I'm going to go ahead and list some of the multiplications, and I won't erase them this time. I'm going to leave them here. I'm trying to find easy multiples of 18, right? Because I would definitely rather not have to subtract 18 over and over and over and over again from 582, because it's going to be a lot of subtraction. Usually, one that I like to start with is multiplying by 2, because it's usually fairly easy to double something. You just add it to itself, right? So 18 plus 18 is really 36, right? And then I will usually multiply by 10, because that's an easy one as well, right? So 18 times 10 is 180, and that's just because we attach a 0, right? And then, so like in this case, would that work? It would. But like, 180, that's still not huge. Like I'd still have to subtract 180 a decent number of times from 582. So like I'd like to get closer to 582, right? So what can you do? Well, usually these can lead you to some other ones, right? And who knows which ones you're going to do, right? So like, for example, 18 times 2. If 18 times 2 is 36, that tells you that 18 times 20 has to be, you would just attach a 0 to that. So that would give you 360, right? So a lot of times just multiplying by 2 and multiplying by 10 can help you find some other ones. So like if 18 times 2 is 36, then 18 times 4 would have to be double that one, right? So 36 plus 36 is 72, right? So you could come up with that one easily. So that means, for example, if 18 times 4 is 72, then 18 times 40 has to be 720, right? So you can come up with some easy ones. Also, times 5 is usually not bad, right? Because if you know what the number times 10 is, then times 5 would have to be half of that because 5 is half of 10. So 18 times 10 was 180. So that means 18 times 5 would have to be half of that, which is 90. And then maybe you would do 18 times 50, right? That would just be 18 times 5 and attach another 0. Now, I did way more than I needed to do here, but I'm just demonstrating what you would do, like some ways that you can find easy multiples without doing any difficult multiplication, right? So like usually 2 and 10 are a good place to start. And from there you can attach zeros. You can do times 4 because you're just doubling, right? You can, you're doubling times 2. You can do times 5 because you're just taking half of the one that's times 10, right? So you can use those strategies. Now, on this one, I'm just going to look for something that's, close-ish to 582. So like, I'm noticing that one's way too big for this problem, right? 720 and then 900 is way too big. This one's decent, right? So like 360, that's a good one. I might go ahead and use that one. But like you might choose to use something different than somebody else, and that's okay. All right, so if I subtract 360, what I really did is I'm really subtracting 18 20 times. That's a huge time saver because I really don't want to have to subtract 18 20 individual times. So then let me subtract here. So this is giving me 222 left over. So then let me look back at my things again and see, is there something that's pretty close to 222? So like 360 worked before, it's not going to work again, right? 360 is too big to go into 222. So like even though this one worked, I don't want to use it again. Can't use it again. What would work? How about 180, right? So if I subtract 180, that's really subtracting 18 10 more times. So let's see, if I subtract, I'm getting 42. We did this one, 18 times 2 is 36, right? So if I subtract 36, that's subtracting 18 2 times. And then let's see, that would just leave me with 6. And 18 won't go into 6, so that's where I would stop. So then I would add my quotients here. 20 plus 10 plus 2 is 32. And I have a remainder here of 6. So let's take a look then at 2,670 divided by 23. I know 23 times 2 is 46. I know 23 times 10 would be 230. Both of those are really small compared to my number here. So maybe attach some zeros. So for example, if I attached another 0 to the 230, that would be 2,300. So that would come actually from multiplying by 23 100 times, right? So 23 times 100 is 2,300. And all I did was realize that I could just attach an extra 0 here and here. So I'm really just using the fact that 23 times 10 is 230. So let's see, if I subtract that, that's going to leave me with 370. Let's see, what else do I want to do? How about I go ahead and do the 230? So yeah, if you want to try and find something closer, you can, but sometimes it's just faster just to go with what you have. So 10 more times would be 230. If I subtract that, that's going to be 140. Let's see, I might try to get a little closer to that. How about, let's do half. So if 23 times 10 is 230, then 23 times 5 has to be half of that. So half of 230 would be 115. All right, half of 200 is 100 and half of 30 is 15. So that would work nicely. So if I subtract 115, I'm really subtracting 23 5 more times. and that gives me 25, and I think I could just subtract 23 just once, right? So subtract 23 from that, and now I would have to stop because I can't subtract 23 anymore. So if I add up 110, 5, and 1, I'm getting 116 with a remainder of 2. So on this next one, my divisor is 52. So let's see, 52 times 2 would be 104. 52 times 10 would be 520. I'm not anywhere close to that 94,651. So I'm thinking let's definitely attach some zeros. So maybe a couple, right? So let's do 52,000. So that would be this one with 2 extra zeros, so 2 more zeros than that. So that would actually be 52 times 1,000 would be 52,000. So let me just start there and subtract. So I'm getting 42,651. Definitely still have a way to go here. Let's see, what do I want to use? We could try and find something closer to that, or we could just stick with what we have. Let's just use this one. So let's see, if 52 times 2 is 104, maybe attach a couple zeros to that. So like 52 times 200 would have to be 104 with 2 zeros attached. That's reasonable. Just go for something fast and easy, right? Like you don't have to find the most efficient thing. And that's kind of not the point, right? Is to find the most efficient thing. You're just finding something that's fairly efficient, that's faster than subtracting 52 a whole bunch of times. So let's see, 32,251. I could probably do that again. Subtract another 10,000. Actually, I could subtract another 10,000 probably 2 more times. So maybe that's a shortcut, right? So if 52 times 200 is 10,400, let's double that. So like 52 times 400 would have to be double that amount, which would be 20,800. So that's a nice shortcut. I'm just looking for whatever you see that's easy. So it's very likely you would not do this one, especially with the bigger numbers. Very likely that your answer would not match mine in the end, because it just depends on what you pick. All right, so I'm getting 11,451, and that was subtracting, let's see, this 200 should go up here. Kind of didn't line that up well. So the 200 was the 10,400, and then this was subtracting another 400 times, right? Because 52 times 400 was that number. So let's see, I could do another 10,400. So that would be subtracting another 200. And let's see, that's going to be 1,051. And guys, if you don't make your bar long enough, it's not like I knew how long to make it, right? It's however long it needs to be. So then let's see what would go into this. Since this starts with a 1, I could kind of work with this idea. So maybe 52 times 20. So if I subtract 52 20 times, so 52 times 2 is 104, so 52 times 20 would have to be 1,040. Oh, and that actually works out really nice. So that gives me 11 left over, and 52 won't go into 11, so I'm done at this point, and I just need to add this up. So let's see, 1,000 plus 200 plus 400 plus 200 plus 20, so I'm getting 1,820 and a remainder of 11.